All right, how's it going, everyone? Welcome. Welcome to another Breakpoint episode. Say hi in the chat if you're here, so I know that you're watching. Yeah, we have a book club for today with a meaty fundamentals of software architecture chapter. And then we're going to continue working on our Redis implementation in TypeScript. So it's gonna be fun. All right, I'm just gonna jump in. All right, fundamentals of software architecture. Fundamentals of software architecture, chapter 3, modularity. So. This is going to be a pretty long one, but it's really interesting. It starts with a quote. 95% of the words about software architecture are spent on extolling the benefits of modularity, and that little, if anything, is said about how to achieve it, by Glenford J. Myers, and he said this in 1978. So bear that in mind. We're going to end with an interesting thing. So, modularity is a way of grouping related code together into modules. It is an organizing principle. To explain it using physics, software systems model complex systems, which naturally gravitate towards entropy or disorder, right? They get more complex, they break down, etc. In order to preserve order in the physical system, energy must be added. And same goes for the software. Architects must actively check and measure the quality of the software and architecture and do things in order to maintain good structural soundness, which doesn't happen by accident. We all know that. Modularity is not an architectural characteristic. Remember architectural characteristics from the previous chapters? Well, modularity is not one of them. There is no project that will have an explicit requirement to have a good modular distinction, right? But every project needs to maintain order and consistency. So it goes without saying, basically. Let's try to define modularity or modules. A module is defined as a set of standardized parts or independent units that can be used to construct a more complex structure. We describe a logical grouping of related code as modularity, and that can be a group of classes or functions, etc. You might think modularity is a developer's thing. Why would architects be concerned about it? Well, because the way that developers package the software, the things, the classes, and the modules can greatly affect the architecture. For example, reusability is much more difficult to achieve, if not like impossible, if multiple packages are tightly coupled together. When we're referring to modularity as grouping of code, we're not referring to physical separation, but a logical one, right? And when we're talking about multiple packages that are tightly coupled together, it doesn't mean that they're in the same folder or, you know, like a physical separation where they live, but a logical one, meaning do they call each other? Do they depend on each other? And how they depend on each other? That's basically the modularity. So there are a few tools which are language agnostic metrics that we can use to measure modularity. And these are cohesion, coupling, and connaissance. So this is a new word for me, and I believe for everyone, because even my computer underlined it with red, says like, what is connaissance, but it actually is a term, and we'll check it out later. Let's start with cohesion. So cohesion refers to how related the parts of the code are to each other, right? A module is cohesive if all of its parts should be packaged together. If we break them into smaller pieces, it would require coupling the parts together with calls or imports between them in order to maintain the same functionality. There are multiple types of cohesion, and they're listed in this case from best to worsts. Okay, first we have functional cohesion. Every part, let me just do this. Every part of the module is related to the other, and the module contains everything essential to function, right? This is like the best, the best type of cohesion, where we have one module. It doesn't have outside dependencies. Everything it has, everything it needs, it has inside. It contains inside. So that is the functional cohesion. Then we have sequential cohesion, the relationship between two modules where one's output is the other one's input, right? That is the sequential cohesion. Think of these as like classes, functions, or, you know, if you're into JavaScript, like npm packages, and how they relate with your code base. Then we have communicational cohesion, when two modules operate on the same information or contribute to some output. For example, write something to the database and then generate a report based on that information, right? Then we have procedural cohesion, when two modules must execute code in a specific order. We're going to see something similar down below, but basically we have, I don't know, we have an email, sending an email example where we instantiate we instantiate the email class, and then we set the header or the sender, we set the body, and then we invoke the send method, and then we set the subject. It's too late, right? So yeah, that's procedural cohesion. Then we have temporal cohesion, when two modules must execute code at a specific time. For example, booting up your computer invokes a number of seemingly unrelated things, but all of them must be initialized when you start your computer. That is the temporal cohesion. Logical cohesion is the data within modules. The data within modules is related logically, but not functionally. For example, a module that converts information from text, serialized objects, or streams, right? And this is, for example, the string utils in Java, right? It's like a utility package that contains a whole bunch of utility methods that are seemingly, you know, the operations are related because they're all on top of the string, but functionally they're very different. So that's logical cohesion. And at the end, we have coincidental cohesion, when elements in the module are not related to each other, other than them being in the same source file or the same file, right? This is the most negative form of cohesion, right? We have one file and it contains, I don't know, 3 functions, 2 classes, and they are not related to each other. That is the worst. That's the coincidental cohesion. So one thing to note is that cohesion is a less precise metric than coupling, and it's often at the discretion of the architect. And here's an example. We have a class, customer maintenance. And this class has a bunch of methods like add customer, update customer, get customer, notify customer, and then we have get customer orders, cancel customer orders, right? This is the customer maintenance. So for the last 2, do we leave them inside of the customer maintenance class, or do we create a new class called order maintenance and keep them there? And of course, the answer, as always, is it depends. You gotta ask yourselves a few questions. Are those the only 2 operations that operate on orders? If so, I guess it's going to be fine if we leave them in the customer maintenance. If the orders operations grow, then it might make sense to separate them, right? Another question, is the customer maintenance class expected to grow? Do we anticipate more customer-related methods or not? That's also a huge factor. Would the order maintenance class require so much knowledge of the customer information? If so, separating them in 2 classes would require a high degree of coupling to make it functional. These questions represent the trade-off analysis. This is at the heart of the job of the software architect. There's a set of metrics. Oh, hold on a second. This is a bit formatted in a weird way. So let me fix that real quick. There we go. We just need a new space here. Okay. There we go. These questions represent trade-off analysis, and this is at the heart of the job of the software architect. I think in the previous 2 lessons or chapters, we pretty much said the same. Trade-off analysis is at the very center of software architecture. You gotta see the pros. You gotta see the pros and the cons of everything. There's a set of metrics named the Chidamber or Kidamber, I don't know how this is pronounced, but Chidamber and Kemmerer object-oriented metrics suite that includes many common code metrics. One of them is called the lack of cohesion in methods, or LCOM for short. This metric measures the structural cohesion of a module, typically a component. We have a math formula provided in the book. So LCOM 96 is the 1/a times the sum of m minus micro aj. I don't know. In other words, this is the formula if you want to look at it. But in other words, LCOM is the sum of sets of methods not shared via sharing fields. And here's also an illustration of the LCOM metric, and this is really going to clear things up. Where the hexagons on the left side represent class fields and the squares represent class methods. So class X on the left, we can see that we have A, B, and C fields or properties, and M1, M2, and M3 methods. We can see that the properties or the fields and methods pretty much use each other, right? M2 uses A and B, M1 uses B and C, etc. So we can say that the class X has a low LCOM score, and that indicates good structural cohesion, right? Y, on the other hand, lacks cohesion. For example, each of the field and method pairs can actually be refactored into its own class without affecting the other fields and methods. So this class lacks cohesion. Class Z, on the other hand, shows mixed cohesion. We can refactor the last 2, C and M3, into its own class without affecting the AB and M1 and M2, right? So this is mixed cohesion. If you're refactoring, of course, this will help you make those decisions, right? That's what the LCOM metric is. It is very useful when moving from one architectural style to another. It can help you find classes that are incidentally coupled, just like we saw here. Have in mind that the LCOM metric does not have deficiencies. It can only find structural lack of cohesion, but it cannot determine logically if particular pieces fit together. And if you remember the second law of software architecture, why is of much more interest to software architects than how. So the LCOM metric, it can only find structural lack of cohesion. Okay, let's move on to coupling. In 1979, Edward Jordan and Larry Constantin published the Structured Design Fundamentals of a Discipline of Computer Program and Systems Design book, in which they define the metrics afferent and efferent coupling. And these are, again, weird words, poor choice of words, but I think they come from mathematics. So, afferent coupling measures the number of incoming connections to a code artifact. For example, references that point to its components, classes, function, fields, methods, and so on. Right? These are the number of connections or the number of places where that code artifact, whatever it is being used, like incoming connections. Efferent is the outgoing connections. That's basically the dependencies of that code artifact, right? How many dependencies does it have? And to make it easier, you can come up with your own mnemonics in order to remember these better. For example, you can think of A in afferent as accepting or incoming connections, right? or the E in efferent as exit or export outgoing connections. So that's coupling basically. How many in how many places depend on this particular, let's say a class, right? How many places in the code base depend on this class, and how many other functions or utilities or classes does this class depend on? That's basically afferent and efferent. Then we have abstractness, instability, and distance from the main sequence. And these are created by Robert Martin. And then these allow a deeper evaluation of the code base. For example, abstractness is the ratio of abstract artifacts. These are, by the way, on the whole code base. So the ratio of the abstract artifacts, like abstract classes, interfaces, type definitions, and so on, to concrete artifacts or implementation. A code base with too many abstractions is challenging to understand how things are wired together. Right? Everything is abstracted. And there's a formula to measure abstractness. It's basically the sum of the abstract artifacts divided by the sum of the concrete, m to the power of c, concrete artifacts. Hold on, my cat is doing something weird. I'll be right back. Sorry about that. Right, let's proceed. This is abstractness. For example, an application that has 5,000 lines of code, all in one main method, right? So it has only one function, it has 5,000 lines of codes, all of them are in one method. The formula's numerator, or the top part of the formula, is 1, while the denominator is 5,000. So it's going to be 1 over 5,000, right? The abstractness of that application is almost 0, because it's not abstract at all, right? Then we have the instability metric. It's the ratio of the efferent coupling or dependencies, right? E for exit or export, coupling to the sum of both efferent and afferent coupling. If efferent and afferent coupling. All right, so this is the formula. The efferent coupling divided by efferent plus afferent. And this is the instability metric. It determines the volatility of a code base. A code base with high degrees of instability breaks more easily when changed because of high coupling. If a class calls to many other classes to delegate work, it's more prone to breakage if one or more of the methods change, right? That means if we have like 5 outgoing, 5 external or outgoing connections, and not enough abstractions, like I don't know, 1 or 0, that's going to be closer to 1, 5 over 6. While if we have not abstractions, sorry, other dependencies on this class, where if it's the other way, if we don't depend too much on other classes, but other classes depend too much on us, changing the other classes is not going to, we don't need to change our class, right? Because it has more outgoing than it has more incoming connections or dependencies than it has other outgoing dependencies, if I explain that well. So that's the instability. And then we have the distance from the main sequence. This is a fun one. And this combines the abstractness and the instability metrics into one. It defines the ideal relationship between the level of abstractness and the level of instability. And of course, there's a math formula for that. Abstractness plus instability minus 1. There's a graph that will help us visualize. So this is the distance from the main sequence. If we chart instability and abstractness on a chart, draw a line between the ones, that's going to be the main sequence, right? And this is like the Goldilocks zone. And if we take our class, our method, our package, whatever we're working on, and we try to calculate the abstractness and instability and map them on this chart, we're going to get the point. The distance between the main sequence and this point is actually the distance from the main sequence, right? And you'll see what this means. This is basically exactly what I said. So there are 3 zones in this chart. The upper right zone is called the zone of uselessness. And this describes code that is too abstract and is difficult to use. The lower left corner is called the zone of pain. And it describes code that is with too much implementation and not enough abstraction. And this makes it brittle and hard to maintain, right? So in order to see where you fall or where your class falls, you need to do this exercise, chart it up, map everything onto this chart, and you'll see where that zone is. But basically, there is no plus or minus in this case. I mean, the book doesn't provide a specific range where this is. It's just a general rule of thumb. The closer you are to the main sequence, like this one, the Goldilocks zone, the better it is. Don't get further away. Okay. And lastly, we have connaissance, that weird word that I heard for the first time. So in 1996, Mailer Page Jones redefined the afferent and efferent metrics for object-oriented programming. And I forgot to mention that afferent and efferent metrics, they're for structural programming. We're talking about C and those structured languages. But in 1996, Page Jones actually redefined this and for object-oriented programming through a concept he named connaissance. And connaissance is 2 components are connaissant if a change in one would require the other to be modified in order to maintain the overall correctness of the system. Classic dependency, right? If A depends on B and B is in a way that if B changes, A needs to change, that means A and B are connaissant, right? And there are 2 types of connaissance, static and dynamic. The static connaissance measures coupling on a source code level, in contrast to the dynamic connaissance, which measures coupling during execution time. We're going to see that later. It's different. But yeah, he defined the following types of static connaissance. We have connaissance of name. Multiple components must agree on the name of an entity. Names of variables or methods are the most common way code bases are coupled, right? Based on the name. And it's also the most recommended because modern day tooling makes system-wide renaming trivial. You can just right-click on a variable if you're using VS Codes, rename the field or the class or whatever, and it's going to change the name in all of the other files where that thing is being used, right? Hey Licando, how's it going? Thanks for joining. And this is a code example of the connaissance of name. We have a function, print full name. It takes in a user object and it prints the user's .first name and the user's last name. Tawan, how's it going? The field names must match to what the function expects, right? We have the user object, the first name and the last name, and this is how we use them. By the name, right? We refer to these by the name, first name and last name. If this changes instead of last name to surname, this function is going to break because last name, that property does not actually exist. It has been changed to surname. So this is connaissance of name, and this is the most recommended way of connaissance. Again, we just want to rename this. We can rename this, and our IDEs are modern. They can figure it out where we actually use all of these objects, reference all of these objects. So of course, it's going to be easy to refactor this piece of code. Hey, Gabriel, how's it going? Welcome. All right. Then we have connaissance of type. Multiple components must agree on the type of an entity. This refers to limiting variables and parameters to specific types. And bear in mind, this is not a universal language features. Like languages like Clojure, they have dynamic typings or selective typing. This is not going to apply in those cases, right? Check this out then. We have a function called calculate area. By the way, these code functions, I came up with them. These are not part of the book. I needed something to, you know, explain these connaissance types with much, you know, with code. Show me the code. Talk is cheap, right? Linus Torvalds. Yeah, so connaissance of type. We have a calculate area function that takes in a shape. And it is similar to the connaissance of name example, but in this case, we have a mathematical operation. We have width times the height. And in this case, we assume that the shape has numeric width and height, because we can't have width to be a number and height to be a string. Right? We cannot multiply numbers with strings, or height being something else, a Boolean, right? Yeah, these two must be a number. So imagine this is someplace else, right? In a different package of ours, and we import this and we use this in a different package. Then these parts, these two must be numbers. This is the connaissance of type, right? Then we have connaissance of meaning, or connaissance of convention. Multiple components must agree on the meaning of particular values. The most obvious case is hard-coded numbers rather than constants. For example, we have a function called isAdmin. We take in a user and we check if the role is equals to 1. And we assume that 1 means admin, right? Then we have the user with the role set to 1. It's not explicitly documented. It's not self-explanatory, right? We don't know the meaning of role of 1, hence the connaissance of meaning. We don't know the meaning directly. It's not documented. It works, right? But if we change the meaning of 1, then we need to update the this function as well. If the admin changes to 0 or 2, if we wanted to, you know, create a super admin and the super admin is going to be 1, but just the regular admin is going to be 2, we need to update everything. And if we do this, especially this way, even our IDEs won't be able to help us. I mean, it's tricky to find where the role is being compared to a specific number. It's going to have to be like a global search of strings, but not references. And sometimes you might have 2 instead of 3 equal signs. So yeah, good luck with that. And sometimes you might even define this above and not like as like a global constant. So yeah, that is the connaissance of meaning. We should, in this case, we should just use constants. You know, define it someplace in the constants.ts or config or whatever, or as like an environment variable, and use that one instead of a magic number or a magic value like this one. Then we have the connaissance of position. Multiple components must agree on the order of values. And this refers to the ordering of arguments. If there's a function update seat where, you know, it takes a name as a string and a seat location as a string, and the developer calls it with update seat 30G and Lazar Nikolov, you know, the types are correct, but the semantics are not correct. We put the name as the second argument, right? But the second argument is a seat location. So our IDE is not going to complain. This is going to be just fine, right? Both are strings, but it's on your responsibility you know, to make sure that the orders or the positions are correct. Hey, Digital, how's it going? Welcome. Fire content. Yeah, this is a pretty fun chapter. Yeah, again, just as we mentioned, update seat, name and a location. Name has been assigned to seat location. If we update the seat with Lazar and 30G, the output is going to be Alice. I didn't change this one. Alice has been assigned to seat 12A. If we swap the seat number and the name, it's going to say 12A has been assigned to seat Alice, or 30G has been assigned to seat Lazar, which is incorrect and it's nonsensical, right? Foxbeat, hello. All right. Lastly, for the connaissance, static connaissance, we have the connaissance of algorithm. Multiple components must agree on a particular algorithm, and a common case is encoding and decoding data. Both the encoding and decoding processes or functions must adhere to the same algorithm in order to maintain correctness, right? For example, we have an encoding function where we reverse and encodes a string to base 64. And the decoding function must do the same, but reversed, right? Reverse the base 64 and decode it again in order to get the original value back. And if the encoding changes, if we don't do the reverse, or if we change it, from base 64 to something else, then the decoding function must also change. So these two functions are connascent to each other based on the connaissance of algorithm, right? There we go. If we have book club, if we encode book club using this function, we were going to get this base 64 string. And if we pass that encoded string, we're going to get back book club. It's going to be the same. All right, then we have, aside from the static connaissance, we have dynamic connaissance. Again, with this analyzes calls at runtime, and there are 4 types for it. There's a connaissance of execution. The order of execution of multiple components is important. And this is that email example that I mentioned earlier. We instantiate a new email, we set the recipient, we set the sender, we send the email, and then we set the subject. It's too late now because the email has already been sent, right? We can't set the subject after sending the actual email. So yeah, connaissance of execution is the order of execution. Tawan asks, could the connaissance of position be solved using a declarative object parameter function, like function name and seat location? This way we can prevent mistakes. True. In this case, the top level or like the actual argument is just 1, right? It is the object containing the name and the seat. And there is no positioning in this case because it's just one object. And yeah, this is how we can solve the connaissance of position. One way. Some languages also support named argument. For example, like Python. In Python, you can literally say open Western. For example, in Python, you can literally say I don't know, assign seat, let's use that one, name equals Lazar, and seat location equals, I don't know, 14A. Even if we change seat location to be the first argument, it's going to be okay because these are named. So the connaissance of position is not applicable in this case if we used named arguments. Yeah. Did you actually see that? Yes, you did. Okay. It wasn't covered by this banner. Cool. Yeah, connaissance of execution. The order must be, the order is important. And the components in this case are also these methods. Right? These are on the same class, but these are still maybe not relevant to each other. There's like a connaissance of, wasn't a connaissance actually. They were, let me see. There's a cohesion. Yeah, they have communicational cohesion, right? They operate on the same information. Or contribute to the same output, right? We have an email. Let's go back. We have an email, and these methods have that communicational cohesion. They contribute to the same object, which is the email, right? And then we send it. Right, then we have connaissance of timing. The timing of the execution of multiple components is important. The most common case is race condition caused by 2 threads executing at the same time, affecting the outcome of the joint operation. Here's a code example that I've seen way too many times in my life. We have a file processing function, we read the file, right? And we assign the data to the file contents. But then we say console.log file contents to uppercase, right? If this is not synchronous, if this is asynchronous, this is going to get executed in a different, it's not going to be a thread in JavaScript, but imagine it as a thread, right? The console log will happen immediately. I'm going to wait for the file to be read and the file contents to be assigned the values. It's going to just console log something to uppercase. This is not initialized, so it's going to break. It's going to say to uppercase of undefined. There's your error. So connaissance of timing. Then we have connaissance of values. Occurs when several values relate to one another and must change together. For example, a rectangle with 4 points. We can't really change one point without considering the impact to the other values, right? If we have 4 points, we have a rectangle. If we change the rectangle's top right point to be somewhere below the bottom right, it might not even be a rectangle anymore. It's definitely not going to be a rectangle, right? So that is the connaissance of values. The other points depend, like points depend on each other. And here's a different example. Again, a read config function that points to a configuration path. It's hard-coded, right? We decided that this is going to be the path where we keep the configuration. We read the file, we parse the JSON, and we console log the config, right? And then someplace else, we have an update config function that gets the new configuration, right? We read or assign the config path again to the same value, hard-coded, and we write whatever's, you know, in the new config there, and we'll say config updated, and we can just update the config. In this case, if we change the config.json location, we have to change it in both places. And this is the connaissance of values, right? These two functions are connaissant to each other because they try to access the same resource through this config path value, and therefore it must be the same. Again, this can be a constant defined somewhere. All right, then we have connaissance of identity. And this occurs when multiple components must reference the same entity. We have, in the main application, we have an object user with the ID of 123. And we log out the user, great. But then in a different analytics service, which is like in a different part of the application, maybe even like a different application, right? If this is like a microservice application, it might even be a different project. We are accessing, we have like a log user event that logs the user event for that user, and we log the user event with 123 as the ID. We basically assume that 123 is Alice, right? And this is connaissance of identity. These two components, the main application and the analytics service, must reference the same entity. If we're talking about Alice, with the email alice@example.com, then these two must be talking about the same Alice, right? That's the connaissance of identity. This is not something that we encounter in modern day times. We have databases, we have IDs, but sometimes if we like hard code or type stuff, if we're not talking about a database with self-assigning identifier, we could run into this. So yeah, that is connaissance of identity. And each of these connaissances, is that the plural form? Each of these connaissances have their own properties, like strength, locality, and degree. Strength defines how easy it is to refactor that type of coupling. Some types of connaissance are easier to refactor than others. I mentioned this, right? We had the name and type. Let's take the name, for example. If I want to change the name of the property or the field in that place, I can just rename it, and the IDE itself is going to find all the references and change the name there. Easy refactor. It's literally just one single execution on the IDE. And the architects and developers can improve the coupling characteristics of their code base by refactoring towards the better types of connaissance. Static is preferred over dynamic because it can be determined by a simple code analysis, right? Our IDEs can do this for us. And modern tooling makes it easier to improve static connaissance. Again, for example, a case of connaissance of meaning, this one, and that was is admin if the role is equal to 1, can be improved by refactoring it to connaissance of name just by creating a named constant rather than using a magic value. Instead of having or assuming that role equals to 1 is admin, we're going to create a constant admin role ID, assign that to 1, and then we can use that in both places, right? So we're refactoring from connaissance of meaning, we're refactoring to connaissance of name. That's it. So these are all the connaissance based on their based on their strength, right? And we should prefer to refactor towards this way, right? If we have position algorithm, we should try to refactor that way as much as we can, right? Algorithm might not always be like the case. If we're base 64, if we implement base 64, then we implement base 64. We can't really replace that with a name or something like that. But yeah, when we're refactoring, we should strive towards refactoring that way, in that direction. Cool. Locality measures how proximal the modules are to each other in the code base. This is like a physical organization. Proximal code has more and higher forms of connaissance than more separated codes. For example, if two classes in the same package have connaissance of meaning, it is less damaging to the code base than if two different packages have the same form of connaissance or the connaissance of meaning. Why? Because within the package, we can have a connaissance of meaning if we can't refactor it towards a type or name. We can have connaissance of meaning. I mean, yeah, ideally we shouldn't have, but if we do, it's going to be less damaging than having two different packages having the same connaissance of meaning, right? Because that can mean different things in these two packages. And if we don't refactor it with a more precise one or a more accurate one, like type or name, that's going to cause more damage, than just like that's localizing the connaissance of meaning within one package or even within one class. All right. Then we have the degree property, and this relates to the size of impact. Does it impact a few classes or many classes? The smaller the degree is, the smaller the damage is. Paige Jones created 3 guidelines of using connaissance to improve our system's modularity. First, minimize overall connaissance by breaking the system into encapsulated elements. The second one is minimize any remaining connaissance that crosses encapsulation boundaries. And third, maximize the connaissance within encapsulation boundaries, right? These are basically refactoring refactoring guidelines. Yeah, so, the first one, minimize overall connaissance by breaking the system into encapsulated elements, meaning don't have one class, don't have a God class. You've probably heard of the term God class, which refers to a class that does way too many things, right? And you can even use the this one, the LCOM, to see if you have a God class or not, or if you can have, multiple and break it down into like smaller elements, smaller classes. That's what the first one refers to, the first guideline. Yeah, minimize overall connaissance by breaking the system into encapsulated elements, right? Minimize any remaining connaissance that crosses encapsulation boundaries. This is that thing, right? If we have multiple classes, but they have to be connaissant, they're doing the same thing or a relevant thing, then we better, refactor towards this way so that it's easier to refactor, or it's less damaging to the code base. and then maximize the connaissance within encapsulation boundaries. That means within the individual classes that we refactored, right? We had one God class, we refactored into multiple smaller classes. Within those classes, we need to maximize the connaissance, just like class X, right? And keep breaking it down until we reach like a really good class X type of class, where the LCOM score is low, basically. That indicates good good structural. Let's see, in connaissance of meaning. When we created a name constant to store this magic number, it sometimes increases the amount of boilerplate in our code. I understand this is the correct approach, but is it sustainable? It is. It's better to have, it's better to have boilerplate code. It's less damaging to have boilerplate code that you can easily update and change than, having a magic number that's like even hard to find. Even search within the project might be hard. It's not going to uncover all of the magic number instances because one is just one, right? So again, we're talking about trade-off analysis in this case as well, right? There's pros and cons. You get a reference and like a LSP reference with the constant, but you also get boilerplate. If I were to pick between one of these, it would have been the left one. I would pick it, I would take boilerplate because it's going to be easier to update later on. Yeah. Okay, so Jim Weyrich, that's the Rake guy. I think he's like a legendary architect. Ruby on Rails. Not on Rails, but just Ruby in general. He repopularized the concept and offers two pieces of advice. Rule of degree. Convert strong forms of connaissance into weaker forms of connaissance. And also rule of locality. As the distance between software elements increases, use weaker forms of connaissance. That's this, basically, based on the strength, right? Yeah. And of course, we should talk about the problems of the connaissance defined in 1990s, because this is already at some degree outdated. There are multiple problems. First, these measures look at lower levels of code and focus on quality and hygiene rather than architectural structure. Architects should be concerned of how modules are coupled instead of the degree of coupling. As you notice, we talked about really low-level code stuff, how we implement things, how we refactor things into like multiple classes and stuff, right? That's not necessarily of concern to the architects at that degree or at that level, right? So yeah, architects should be concerned of how modules are coupled instead of, actual implementation details. And second, it doesn't really address the fundamental decisions that many modern architects must make. For example, like, should we use synchronous or asynchronous communication in distributed architectures like microservices? Coupling in connaissance and stuff like that, it's not going to help you make that decision, right? But in chapter 7, we're going to see new ways to think about modern connaissance. It's updated. I haven't read chapter 7 yet, so we'll see. We'll see what are the new ways to think about modern connaissance. But yeah, this was chapter 3, modularity. You can find the source code on my GitHub repo, Fundamentals of Software Architecture, on my account. And yeah, the next chapter is the architecture characteristics defined. We're going to talk about the ilities, scalability, and what else was there? Security is not an ility, but yeah, security, elasticity, testability, and stuff like that. So yeah, that's going to happen next Wednesday, I would like to say, but I think I'm going to skip that one. So instead of live stream, I'm actually going to post a video of summarizing this chapter 4. But yeah, this was chapter 3. Let me actually post the link here in the chat so you can access it without needing to type in. There we go. Did it go through on YouTube? There seems a downgrade. What happened? Did my stream... Something with my stream? Oh, the downgrade of my hair. Exactly. I thought it was the stream, but yeah. Yeah, I have a new design library or design system with short beard and shorter hair. All right. Next up, we have 1 more hour, and we're gonna continue working on our Redis in TypeScript. We are literally rebuilding Redis in TypeScript. 20 years younger. Funny thing is, this is how I looked like 10 years ago. I started growing my beard out when I was 20, give or take, yeah, somewhere around first year of university, something like that. And I thought you might be looking for a job. Yeah, cleaned up, you know, gotta look fresh for the interviews. But yeah, I spent my 20s looking, you know, with a long beard and various lengths of hair. And last summer I turned 30. So I'm already 30, and I thought, you know what, let's make this decade a bit different in terms of looks. It was good, yeah. It was again, it was like at various lengths, at various levels of you know, looks and maintenance. But yeah, I thought I already achieved a wizard level. I've had it, like, I think towards like this level. What more can I, you know, achieve in terms of length? So yeah, that's why I decided to, you know, that's why I decided to like cut it up. Yeah. Yeah, I'm gonna look like this, plus minus some changes, for the next 10 years. Short hair, long beard. Yeah, that was my favorite period. I actually trimmed my hair at home, just like clippers. And I think I put like 3 millimeters or 4 millimeters of the clips guard, and just like did like a buzz cut at home. And yeah, I do have like a thick hair. So far, nothing is missing. No holes, no patches. Are you planning to do DSA videos one day, or do you have interest on this subject? DSA? Was that like what was DSA? What are you referring to? Oh yeah. Shout out to our wives. I also relied heavily on my wife to clean up the sides and stuff. Data structure algorithms. I don't have anything planned for like data structure algorithms, but it could be fun. I do have a, let me see if I can like pull this up right here so I can show you what I have planned. Okay. Notion. There we go. I have this planned. Design patterns. So not really data structure algorithms, but I put a list of like 15 design patterns that we can go through, like the command pattern, factory, observer, singleton, builder, adapter, bridge, you know, stuff like this. And just like basically explain everything, draw some diagrams, some code examples as well. So I'll just like have a GitHub repository where we, you know, visit all of these design patterns. Yeah. I mean, I think it's gonna be like a good learning resource that we can create, you know, for like anyone looking to get into this. Yeah, it's gonna be pretty cool. All right, yeah. Are you ready for Redis in TypeScript? There we go. Oh, let me actually share you the referral. I'm gonna post this because if you plan on, wait, was that it? No, that was not it. If you plan on actually getting this, go to partner dashboard. Yeah, if you plan on getting the, do these come through, like I'm actually sending the links, as you can see here. Do these actually come through on YouTube or not? That's weird. I see that Twitch is reporting it. Huh, that's very weird. I definitely need a better solution for this, the chat. Let me try to sign in. Annoying. Okay, I am signed in. Let me, thanks for your patience, y'all. The chat is not chatting. Okay. It says that I'm signed in. Let me test. Should come through both platforms. There we go. Okay, so I've been sending links, but none of them went through on YouTube because the tool is connected with something terrible. But yeah, if you plan on getting, if you plan like on getting the CodeCrafters, here's a link. You can join. You get like 40% off, and I get 60%. So, which is cool. You know, it's gonna be cheaper for you. I get some of that money. We win for both of us, right? All right. Let's see where we were. Read a key. Let me open. Western. We did the CodeCrafters tests in order to test our solution, and we'll get into the lesson right away. Oh, number. I sorry, I didn't address you. Thanks for tuning in. Yeah, have a good night. There we go. Okay, expected array type, got a simple string. Cool. This is the actual lesson that we're gonna work on. Right. So in the previous one, we solved having like a config file, RDB config file, and we kept a bunch of key value values, key value pairs for the configuration. And now we can continue adding support for reading a single key from the RDB file. Okay, there are different sections in the RDB file, and this is in the order: header section, metadata, database section, and the end of file section. This is basically it's a binary file, and it's split into like 4 sections with some delimiters annotating the start and the end of the header, metadata, database, etc. At least I assume, we'll see. RDB files are special encodings to store different types of data. The ones relevant to this stage are size encoding and string encoding. These are explained near the end of this page. The following breakdown of the RDB file format is based on Redis RDB file format by Jan-Erik Rediger. Yeah, we've only included the parts that are relevant for this stage. RDB files begin with a header section, which looks like something like this. A bunch of numbers, right? This is a magic string plus the version number in ASCII formats. Redis 0011. The header contains the magic string Redis, followed by a 4-character RDB version number. There we go. REDIS 0011. In this challenge, the test RDB files all use version 11. So the header is always Redis 0011. Okay? Basically, we can look for this, and we can like split it at that point after this index and have the metadata start. Next is the metadata. It contains 0 or more metadata subsections, which each specify single metadata attributes. Here's an example of a metadata subsection that specifies Redis version. So FA indicates the start of a metadata subsection, which means we can look for this for the start, and then everything before that is the header. From this point on, it's the metadata section. And then we have the name of the metadata attribute and the value of the metadata attribute. So it's like a pair of lines, as far as I can understand. Name, value, name, value. They're always string encoded. Yeah. Then we have the database section, which indicates with FE the start of the database subsection. All right, so yeah, we can use this. We're definitely going to use these flags, basically, to split up the input so that we can parse it, decode it, and act on it. The index of the database, it's 0, indicates that, and this is size encoded, indicates that the hash table size information follows FB. The size of the hash table that stores the keys and values, size encoded, in this case is 3, and the size of the hash table that stores the expires of keys, also size encoded. Okay, then the 1-byte flag that specifies the values type and encoding. Here the flag is 0, which means string. Oh boy, this is going to be fun. There's already too much information. The name of the key, string encoded, it's full bar, and the value, again string encoded, it's bas quicks. And then FC indicates this key, the previous one, foo, has an expire. Isn't it foo bar? I guess, okay. Has an expire, and that the expire timestamp is expressed in milliseconds. This is the expire timestamp, Unix time, 8 bytes unsigned long in little endian, right to left. Okay, the expire timestamp is this. The value is string, the key is foo, and the value is bar. Okay, I get it. So in this case, we have this is a different key, I guess. So we're talking about multiple keys. First, we set the expiry. Then we set the type of the string, and then the key itself, and then the value itself. And then we have another FD, indicates that this key buzz has an expire timestamp. In Unix time, 4-byte unsigned integer, little endian, that's the timestamp. So this one is a 4-byte integer then. The value is a string, 00, buzz, quicks. Oh, I got it. Okay. Okay, let's see. First, we had the database section. We had a start of the index and then the hash table. The size of the hash table that stores the keys and values, it's like 3. Okay, and the size of the hash table that stores the expires of the key. In this case, it's 2. The 1-byte flag specifies the values, type, and encoding. Isn't this like for everyone? For every value? Or this is just for the hash table, basically? Right. And these are like all of the keys. As you can see, it's foo bar. The first one is foo. The second one is bar. Actually, no. It's one row. And it's not the key. It's actually the first entry's key value. And then we have baz quicks. The key is baz. The value is quicks. Okay. Hopefully, this is going to be much clearer when we start writing some code. Yeah, all right, let's see. More formal description. Optional expire information. Timestamp in seconds. FD expire in seconds, 4-byte unsigned, or in milliseconds. If it's in seconds, it's going to be D. If it's milliseconds, if C, it's going to be 8-byte unsigned long. Then we have the value type, 1-byte flag. Then we have the key, string encoded, and also value encoding depends on the value type. And this is the value type. We receive it as like a 1-byte flag. And in the end of the file is FF. And then we have a checksum. An 8-byte CRC64 checksum for the entire file. Whew, all right. Let's move on. Size encoding. Values specify the size of something. Here are some examples. The database, index, and hash tables sizes are size encoded. Yeah. String encoding begins with a size encoded value that specifies the number of characters in the string. Okay. List encodings begin with a size encoded value that specifies the number of elements in the lists. The first 2 bits of a size encoded value indicate how the value should be parsed. Here's a guide. Oh man, this is if the first 2 bits are 00, the size of the remaining 6 bits of the byte, in this case, size is 10. The first 2 bits are 00. The size is the remaining bits, 1, 2, 3, 4, 5, 6. In this case, the size is 10. 8 plus 2 is 10. So that's 0, 8. Okay. If the first 2 bits are 0, 1, 0, 1, the next like 14 bits, the size is the next 14 bits. Remaining 6 bits in the first bytes. So that's 1, 2, 3, 4, 5, 6. In big endian, combined with the next byte. Huh. I still don't like this might not be well explained, but like this is the file format. I think we should start with like here's some data, and you know try to encode it in this way so that we can understand this better. Just by looking at it, I don't see this. What are we even like? This is the size encoding, but I already lost my way of the bytes that we're looking at. Size of the string and the string itself. So this is like 13 characters long, and this is the string itself, and the first is the size that specifies 13. With 0b11, the remaining 6 bits indicate a type of string format. Okay, that was very confusing. The keys command. Okay, let's move on. The keys command returns all the keys that match a given pattern, like an RESP array. We already have a utility for this. Set foo par, it says okay. Set pass quicks, it says okay. Give me the keys. F star. Oh, star is like a wildcard. Give me the keys that start on F. F and then something else, whatever it is. It returns foo. Yeah. If we just return a wildcard, then we need to return all of the keys, basically. So in this stage, we gotta add support for the keys command. However, you only need to support the star pattern. Right now, we just need to support the star pattern. Nice. Okay, so our program is going to send the keys command, and we just need to return all of the keys, basically, in an RESP array that contains the key from the RDB file. This is going to be very easy. Very, very easy. Let me just register the commands, the keys command. And then we'll just get it here. If we're talking about keys, the output is going to be, we don't even have the keys command at this time, so let me just, it's not going to be a bulk string. I think it's going to be array. Yes. I'm going to drag this over here. And rename this as like the keys command. So I'm gonna go back. Bring in the keys command, send the DB and the parts. And break out. There we go. Okay, now we're in the keys. And the parts are going to be just the we actually get the, not the key, but the key that we're requesting. And it's only going to be star. So the only thing that we want to grab is all of the keys from the config, right? So that's the key. And we'll say if the key equals to star, which we will, you know, it will, at the start. Let's just do like an output. In this case, the output, not append, but like push. We're going to push object.keys on the config. Config, right? Or not? No, this is not actually the config. We need the database, not the config. Yeah. I don't care about the config. We just want to do DB. There we go. And we want to just to RESP array the output. Oh. So I should like split these. Or do this. Is there any type? No, it's going to be a string type. A string array. There we go. Okay, so we are taking in the key. we're checking if it's a star. If it's a star, all good, right? You can just do this. Actually, let me actually do this. Instead of doing this, we're actually gonna regex this. Okay, so output is going to be object.keys of db. And we're going to filter out all of them based on the key that we accept. And we'll just pass the key into a regex, right? So we'll say dot filter, okay, and we'll say, we're going to say not key as in key. Let me actually try this. Generate actually share the buffer so it knows. There we go. The keys.ts. I'm gonna tag full stack dev. Generate a regex that filters all of the db keys based on the key value defined on line 5. Okay, I want to see how we can create a regex. Or we can just do instantiate regex and then just do .tests. Yeah. Pass in the key. And what we need to do is just do regex.tests and then pass in the key. Nice. This can be const now. Right, so here's the regex. If it's star, it's a star. So we're gonna get all of the keys in the whole database, and then we're gonna filter them out based on the one that's passed the regex, basically, based on the key. And we'll just return the output. Okay. CodeCrafters, tests. Let's see if this works. Nope. No, it doesn't. Expected array type, I got a simple string. We are returning an array. Just like we do in the config. Come on, let me just restart the LSP. Made some changes in my NeoVM config, so not an editor command. Jump to single result true. Huh. Hold on. Let me see what's up with this. Jump to single results. Jump to single results. Oh, so apparently I broke this. Yo, how's it going, man? New year, new haircut. Yep, looking fresh. Here, if you want a better look. Trying to fix this jump to single result thingy. Let me see. Definitions. Jump. Okay. There we go. It was me 3 days ago. Okay, let me just quickly try to fix this. Should be here. Yeah, you see? So I guess it's like the formatting or not. Why did it work before and not now? GD, fuzzy finder Lua, LSP definitions, jump to single result true, ignore current line true, then return. I'm gonna bring these back. Delete these 4 and do style ignore, was it? Yes, style ignore. But I want the whole block. Okay. Let's try this again if it works now. There we go. So it is the formatting. Hold on. Do we have like more symbols for the document? That works. Symbols for the workspace, that works as well. Nice. Search for grep, we've already tested that. Workspace diagnostics, no diagnostics, but it actually works. Document diagnostics, okay. These work and now I just made these work as well. So yeah, fixing fuzzy finder Lua key maps. Nice. There we go. All right, back to the actual code. I want to log out the parts, the key. Hold on, not in config. Jesus. Let's go back to the keys command because that's what we want to see. Yeah, console log. Give me the key and also give me the regex. Actually, the regex is the key. We don't need that. Give me the output. Test. Oh. Four keys. This looks like the command, maybe. Parsing the command, because it's 4 keys. And it goes to the default because it's not recognized. Where's the command? It is undefined. So yeah, we have issues with parsing of the command. Just log this one out. Definitely not gonna have a match because that's what we're looking for. I just want to see the hold on a second. I think I got this. So 4 keys. That means there's 4 letters. But it should have matched it, regardless if there's like a number before it or not. Let me just grab this whole data string so I can play with the regex. We have this regex, so it's like -b, and then keys inside. Oh, it's not matching because I'm in a word boundary. That's the thing. If I have like a dot here, it's gonna match because that's the number of, you know, the number of like letters, and there can be a 1 or more or 0 or this can be like a where's the regex. This is going to be much better. So a word boundary, but then and optionally 0 or 1 characters for, you know, before the actual command name. I think the matching should be okay now. We should have the match. Let's try that again. Okay, so now the output is empty, but the command is matched, so that's good. It needs to send it needs to do a bunch of sets before. So I'm gonna try to console log the whole DB and see what we have in the database. If it's empty, it is empty, you see? Okay. If it's not doing any, the RDB file provided by directory and DB file name might not exist. If the file doesn't exist, your program must treat it, the database is empty. Okay, let's see what we did back then. We have the data string, the commands, and the DB. Yeah, the DB is still. Yeah, it is still an empty. Let me see the config. There's a directory. And the file name is grape.rdb. It's in non-modules. grape.rdb, because it only, as far as I can see, the only thing that gets outputted is like the keys. Tries to get the S, the output is not. It should have had at least one element. Where is that file? I don't think we have the. I don't think we have the file. This one, the DB file. Use the save command. We can use the save command. But then we're gonna need to do the parsing. And I don't think that's in this lesson. Right? From an RDB file. Oh, apparently, create an RDB file with a single key. So it did create a single key. Also, the key is set to S. That's not correct. That's not correct. Should be star. Yeah, see? So now we still have the issue here where we break out, you know, the actual data string here. Yeah, the command.length, as you can see, it doesn't take into account whether there was a like a number before that or not. So we need to be better with the CMD length. Instead of doing that, we have the match. We have match.index. We also have match.length. So we should have been using match.length. Now parts should just be 1 star and that's it. Which of course we do need to decode that. Yeah, keys and 1 star. The key is not key. So now everything is, damn it, no. Match.index, match.length. That's the index, parts index. And if we split that, let me see the match length. It's just 1. Why is that? That's the issue. There's indices. Which is undefined. The length of the array. This is a number 1 higher than the highest index. So if we have like a, because this is an array, right? If we have 0 dot length, we should have the first match and the length of it. So it should be like 4, 5. Yeah. Keys 4 plus 1. There we go. That's actually what we want to do. Not the length of the match array because there could be like more matches. But the actual first match, I believe we can even do this or not. This is the index of the search at which the result was found. Okay, so match is a regular expression match array. That means we need to get the first match and then print out the length, get the length and add it to the parts index. And now there's not going to be keys. There's just going to be just one star, and we need to like decode that from an RESP string. There we go. The key is 1 star. So we need a utility. You see that to RESP bulk string, we need to function from RESP bulk string. We're going to get the not the payload, but okay, yeah, let's get the payload. So name it the payload. Otherwise it's a bad name. It's gonna be like just RESP. Yeah. There's a string, and now we need to split it based on, we need to regex it basically. Get the number regardless of how many, you know, regardless of how many numbers there are. Get the number, and then everything else after that number should be the string. Okay. We can actually do that with regex as well. Something like this. Something like this. So check this out. It's not going to be a word boundary. Let's go to regexer and actually do 4 keys. We can also do 13 for just like 12 keys. That's like 12 letters, and these are 4 letters. So if we do now, what should we do? It should be multi-line just so I can see. I think we need 1 or more numbers. So from 0 to 9, we need 1 or more of them. And then we're gonna create a capture group, and everything that's from A to Z plus as well. There we go. So this capture group that we created is going to come up with the match. So I think this is the regex that we want to apply. Just like straight away. This is it. Just replace these with like regular strings. Okay, here's the regex, right? And we try to match it, and let me just like log out the match. I want to see the match here. I'll go back to the keys, and where we have the key, I want to do the from RESP bulk string, and I'm gonna pass the parts 0 and import this. Return match dot. What did we do? Oh, we'll just return RESP in this case. Yeah, we'll just return RESP. And I'm going to rerun this, rerun the test again. See if the match is correct. What did we do? We just console log the match, but it's null. Okay. I'm gonna remove all of these logs because we can see. We can see everything now. Need to label these just so I can have it clear. I mean, there's like 2 of them, but still. So the RESP is 1 star. 1 star. If we say 1 star, yes, it does not include this because we just say A to Z. See that? So in this case, we don't want this. We just want dot plus instead of A to Z plus. So apparently, yeah, it can be a string as well. So dot plus. Now we should have the match show up. Shouldn't be null. There it is. You see that? So the first match is the whole string, and the second one is that group that I created. It says groups undefined, but I don't know why. It's the second group that I created. So we can pull out the second element from the match. And we're gonna say return match, and give us the second element. If match exists, otherwise return RESP. I don't know about this. Unsure of the side effect. I'm not sure about the side effect of returning the same RESP string. I don't know. We're gonna have to see. But now we have this, right? When I say key here, we should have that key. Did I remove the console? No. I'm gonna remove the RESP. There we go. If I log out the key, we should see just star. Not 1 star. Yeah, the key is a star. There we go. Yes, that's the key. And regex now throws an error because it says invalid regular expression, nothing to repeat. Interesting. On line 5. It's not actually on line 5, right? Yeah. Oh, because this type is not in, yeah, line 5 here. Should be here. Let me actually try that. Yeah, it is true. Invalid regular expression, nothing to repeat. Right. So let's say that we have mango, apple, something else. And the key was a star. Yeah. So that's not even, I mean, a star in regex does not mean a wildcard. No, we need a dot in that case. A star should be a dot. Not because a star is it's like a quantifier. It's 0 or more, as you can see here. That's what the star means by itself. So we need a dot to indicate any character except new line. Right? If this was a dot, it would have matched. Would have matched everything. So we need to convert that wildcard into a, from a star into a dot. Because yeah, that's what a star means, any character. Okay, so Let's do this then. Replace. I'm gonna start simple. Replace the star with a dot, and then we'll see what. Then we'll see what happens. I don't want to be smart. There we go. This is fine. I don't want to be smart before I actually know what's going on. Let's see what happens now. One element, but got 0 elements. What you say? I want to expand this. Let me see the key. And the key is going to be undefined. Of course, it's not even being printed because why? DB is empty. DB is empty. It is sending us. It is sending us some temp file. Let's see. Where is that? TMP RDB files strawberry.rdb. I don't see it. Are we supposed to like create that file? Because it says created RDB file with a single key. But where? Use the save command. Yeah, I guess we can do that. Let's try that. Let's try this and see. I mean, we can create like a RDB file, but should we do like the whole parsing in this case? Looks like it. It looks like we need to create that RDB file, parse the whole contents. Man, this is too much. I mean, it's like a really this is a long lesson. It's gonna take like at least 2 streams, and we're already done on time with the first one. But it's, yeah, doesn't matter. This is what it is. This is gonna be fun. Case star. Yeah, I guess we're gonna have to. I'm gonna put it to do because we won't have time. Create the, let's see, the RDB file is not created. Your DB is a plain record. You need to create the RDB file, look at logs, parse it, read its contents, and then return keys from its contents. And I can see that it says created RDB file with a single key, but I'm not sure. I'm not sure how it's doing that. And where is that file? Yeah, looks like it doesn't exist, so that means we need to create this. We need to create this file, and then we will be able to RDB files, strawberry RDB. But the thing is, it's always a different one, right? It's strawberry RDB. Now it's banana RDB. Then it was orange RDB. Pear RDB. And what is that command? What is the actual command that does that? Right, because I am printing out the data string here, but I just don't see the command here. And this directory doesn't exist. Yeah. The directory doesn't exist. I know we should be able to create it. Yeah, this one is also different. I guess we should create that RDB file in this thing, but it says created RDB file with a single key. How are we gonna react to this? That's the thing. How are we gonna react to this? Because we can see that we have config pasts, but I don't know. And that's just on data. I guess we should like make the event. It's not data. What is the command was save. Save. Well, let me actually do this. Okay? We got the save command. Oh. Save. Okay, just because we want to see it there. And we don't care about the error. It's just that it's not gonna fail. There's no save. There is no save. And most likely yeah. I have no idea what we should do here. How do we make sure that the actual file is created? I mean, we do have this console log. Just like make it like this so I can see if it, gets in there at all. Okay, yeah, so it does get in there. This is the command, but it says created RDB file with a single key pineapple. With a single key pineapple. But the file name is orange, right? Let me just print out all of the args. Maybe it's like a, I don't know. Yeah, so the directory is this temporary. The DB file name is pair.rdb, but there is no banana. It says created RDB file with a single key banana. How can I parse this? If I wanted to create the file, I'm not sure how I can parse that. Very weird. Yes, I know. We can do that, but this means that we need to dynamically do that. This is an example RDB file. We can just say save and that's it. It calls a set with a key. And I was expecting to see the set command being executed when it claims that, you know, it creates an RDB file with a single key banana. This to be actually the set command to be invoked, and we don't see it here. Because this is the data, this is what we receive first. Let me see. See the debug. Oh yeah, look at that. That's the RDB file contents. Pineapple.orange. Sent bytes keys star. That's the keys star. Received bytes 0 and test failed. Where is it? Where's this RDB file? Oh, hold on a second. Maybe it creates the file in the temporary and then immediately deletes it. It doesn't leave it just there. Let me try this. Let me actually try this. If that's the case, then we don't care. We can just like read it and we'll try to parse it. So parsing is a huge part of, you know, this lesson. But yeah, I'm gonna set it into temp and I'm gonna open this here as like a file, right? Let's try this. Let's see if I run tests and we can see something appear there. It wasn't there. This is /temp. This is that directory that, you know, it points to. And I use that for my download. So when I restart my computer, all of those temporary files get automatically deleted. But maybe it does. Maybe it does include that. Let me check the socket API, the events at least. Probably on connect is what we're looking for. Yo, BS. How's it going? We got the data. I think we should do like the connect part or the ready. Let's do both and see what happens. So connection.on ready. We probably don't have any data, right? There's no data. It's just a connection. I'm gonna log it out. And then we'll do on connect. Connected. I'm gonna say connected. Been a minute since you popped on my channel. Good work. Thanks. We're trying to make this work. So none of that got logged, right? None of that got logged. Why is that? This is the only log. This is the only console log that we can see. So connect doesn't work. Ready doesn't work as well. We don't get the console. Right? I'm not tripping. Yeah, we don't get the console. So when am I supposed to, I guess right here when we have the config stuff, read the db file. Yeah, I guess that's when we need to do that. And when we read, successfully the db file, that's when we need to do server.listen. Let me actually try this real quick. I think we should be able to do this fast. And we're gonna use AI. Give me this buffer. And let's do full stack developer. Read the file that's located at config. Damn it. Config directory / config db file name. Okay. Python. Are you crazy? It's a TypeScript file. Do it in Python. Oh, no Python. Do it in TypeScript. Wow. Python. Our jobs are safe. Our jobs are safe. Okay, there we go. Read config file. We're doing this in a synchronous way. And I'm actually gonna do it here. Yeah. db rdb path equals path and import path from path dot join config directory and then config db file name. RDB content equals file system, just fs read file synchronous RDB path, and I'm not sure if it's gonna be UTF-8, but let's just see. DB content and another log. RDB content. There we go. And then we are going to start the actual server. But I'm curious to see if we actually see anything. Oh, there we go. Yeah. So the file exists. We just need to parse it, right? So very nice. This is the beginning. This is the what was that? The header, metadata, and then we have the rest of the stuff. So yeah, we do have the RDB content, and we're not just going to do this now. To do parse RDB content and populate the database, or like just populate the DB. Might need to change its type as well. Yeah, we might need to change the type because we do have some information in the header, information in the metadata. We need that, so we need to parse this. It's definitely not going to be UTF-8. What else is there? Hex, I guess, or binary. Let's try hex and see what we get. Oh man, I'm not logging it out. And I also undid the to do. We'll get it back. Okay, this is the database content. It's definitely not, I don't think it is. I mean, we can see it from the top here. 52, 45, 44, yeah, 49, 53, 30, 30. You see that? So now we can grab this string. We can split it into like pairs and try to convert those hex codes into where is it? Do the string and size encoding stuff. Yeah. Let me see, hex to ASCII. If I do 52, it should be R. It is R. Yeah, it is R. So I just need to like convert most of these, right? At least the ones that are string encoded. The ones that are, you know, 0, 0. Let me see if that works as well. Yeah, 0, 0 does not work. So we're not talking about ASCII. We're talking about hexadecimal to what? Definitely not UTF-8. I guess yeah, hex is just hex. It's like a number base. So we need to pull a number out of it. And I don't think I can see that here. It's not in these lists. Yeah, for ASCII, definitely 52 is R. What else did we have? Let's try REDIS 53. And let's try 53. Should be S. It is S. And then it says 30, 30, 31, 31. So this should be 0, 0, 1, 1. There it is. Okay, so when we talk about string encoding, we're talking about just plain hex to ASCII. And in JavaScript, how can we do that? Hex to ASCII. We can do... Can we try to parse? No, there's like a char character data. Oh, there we go. So this is for the number encoding, right? 0, X. Let's try some of the number encodings here. Yeah, 0, 3, 2. We should have something else as well. Unix time. Let's try this one then. 1572 E7 078F 0100. It's not the number because this was little endian. Read right to left, so maybe we should convert that, flip that. 000010 or no, 01 actually. 01 8F 07 E7 72 15 171. There we go. 171 382 455 96 37. So we can convert this number as like something like this, and I'm gonna copy this actually, and we can say parse int. Can we say parse int 0? Well, we already have that 0x 637. Yeah, we can just say parse integer, pass that as a string, right? Pass that as a string, and it's going to give us the timestamp. That's for the number encoding, right? We had the two types of encoding, the size encoding and string encoding. Size encoding, parse int will pass whatever hex we get from the database, and it will give us the number. We also have a string encoding, and I'm trying to figure out how we can do that. JavaScript hex to ASCII. I think it was like a straightforward thing. String from character code, parse integer, and that's it. Oh, we can also do like buffer from input and pass in a hex. Oh, but this is for Node.js. We are using Node.js though. Yeah. We can use the buffer. Let me see. Buffer from, I mean, buffer is gonna be, yeah, buffer is not defined in the browser. Am I stupid? Yeah, buffer is not defined in the browser, but if we try to use it in the script, it should work. It should just work. Or we can just like try string from character code. Like this, let's see. We can try 52 here. 0x52. See? And then we can say plus string from character code 0x45 should give us E. Yes. So if I just like, if I do this whole thing, let me see. If I do this whole thing without the spaces, nope. Because this is not a, or we can actually do, yeah. Got it. 52, 0x 45. Yes. Okay, so check this out. I'm just gonna paste this whole bit here. Then I'm going to say split on space, right? And then I'm gonna say map. I'm gonna get the character, and I'm going to return string from character codes 0x, and I'll pass in the C. And then I'm gonna say join. There's the hex 2 string Redis 0011. Okay, so yeah, this is how we can do the string conversion. This is how we can do the size conversion, or the size, what was that? Encoding, size encoding, decode sizes like just with parse int 0x and then pass in the hex code, and then do the split from char code, join if we wanted to convert the hex code to just simple ASCII, simple strings. And this is how we're basically going to read all of the keys, parse the whole file, and populate the database in memory. the one that we have, because that's Redis. It is in memory, but when you start the server, Redis will read this file, you know, the RDB file. It will read the RDB file, and it will populate everything in memory, in like a, you know, in our case, it's just like a regular record. And then all of the commands, when it does, you know, work with the commands, it will actually work on with the records and not with the file. Occasionally, it triggers like a save snapshot command that saves whatever is in the record. It saves it into like a new RDB file, and that's how Redis works under the hood. But yeah, we got it. Let me just, because we're gonna do this next time, I'm just gonna do these commands into the code so that we can, you know, there's the RDB code to do parse RDB file, and I'm going to say size encoding. We're gonna do it like this. Yeah, that's fine, you know, like this. Like this, whatever we have, you know. And then for the string encoding, we want to do this basically. Which is like the hex again. This is the hex. Split it, map it from character code, join, and that's the string encoding. So that's how we can parse or like decode the RDB file contents. But we need to look for the flags, you know, like it begins with the header section, but we need to find the FA. Once we find the FA, we need to, oh yeah, yes, and this is like, it's basically like a single string. We need to split everything into pairs first. Split into pairs of hex codes. File is a single string without spaces. Split into pairs of hex code. For size encoding, you can pass the whole thing, or if in this case we need to, you know, split it into pairs so that we can isolate all the characters. Because this worked. This, I mean, of course, this was the size, right? Yeah. Everything is like mushed together, but depending on what it is, we're either going to use parse integer to get a number out of it, or do the trick to get a string out of it. So this string has like mixed encoding depending on what it is. But we should be looking for the FA. There's the FA. So this is where the header ends. We're just going to look for it, grab it, and get the header. And then the metadata starts, and we should look for another FA, if I'm not wrong. Where was it? Metadata starts with FA. Database starts with FE. Okay. Database starts with the first FE, technically. There's FE, and this is where the database starts, and it goes all the way to the end. Was there an ending section? There is an end of file section. And it's FF. And there's FF. Okay, so this is the database. From FE to FF. That's fun. Let me actually try that. We have the RDB content. And we need to find the header. RDB content. dot slice from 0 until RDB content index of FE. That's the header. Or maybe I should do like header index is RDB content index of capital O FE. That's our header index, right? Then we have the, it's not the header index, really, it's the metadata index. Then we have the database index, and that was RDB content. FE. Again, FA was the metadata, FE was the database, and then we only have the FF for the file ending. FF, right? So from the header, from 0 to the header index, which is actually the metadata index, we have the header. The metadata is going to be RDB content.slice from the metadata index. We should see if we should do like +1 or something like that. We'll see. From the metadata index to the database index. The database is going to be from the database index to the file ending index, and then the file ending is going to be from the file ending index to the actual end, RDB content.length to the last one. So I want to log out all of these. Oh. Bam. Let's see. See if we split them correctly. Okay, the header 30, 30, 31, 31. That's correct. Right? And then we have the metadata, and it starts with FA because it includes the index. And it ends with 040. 040, and then we have FE for the database. Beautiful, look at that. And then we have the file ending, starts from FF, and it goes on. 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs of hex code. Nice. We can actually omit these because we don't want to convert them. Right, so it's going to be metadata index +1 or 2. Let's see. Should be 1 or 2. Should be 2, of course. I don't know why I've never like felt any confidence when working with these index. Sometimes it includes the index in the range, sometimes it doesn't, so you gotta do +1 if you want to include it. So yeah, it's best if you just check. There's the header. And now, let's just like for the fun of it, I'm gonna try to do the parsing thing. Console.log. We gotta split it into pairs first, right? Because we wanna do 0x, 0x. We gotta split it to the pairs first. JavaScript split string into pairs of characters. Are we gonna use like a map? Not a map actually, but like a reduce. Now we can like do this basic, right? Just regexit. Interesting. So if I do this then, I didn't know that. That's pretty cool. If I do this, I'm gonna grab this. Do this and then dot match. And what was the... dot question mark and then G. Oh, look at that. See that? Beautiful. So we can actually do header dot match. Oh, other way. Dot question mark, right? Dot map, get the character and pass it through the string from character code 0x and then the character itself, right? Hey, thanks for following. We got this. Then dot map. What was that again? I had it below. We did the map and we just need to like join this. Right. And it's possibly null, so let's just do this. It's an assignable type of number. Oh, so it's not gonna be like a string. Right. It's going to be like directly as like this. But how can I... This is a C. Right? Should I do like a parse int maybe? Inside? It's gonna be 82. So it's not even an integer. Okay, how do we convert this? Let's try the robot. Maybe it can help us this time. How do I construct a hex code of type 0x52 using using a variable C that holds the 52 value as a string. Okay, go robots. Parse integer and then we can do like C16, but it's not a maybe it is. It should actually do that, right? 82. If 82 is the code, then string from character code 82 is gonna give us R. Yeah, that's it. Okay, cool. Very nice. So I don't need to like convert these. I can just like parse integer. Parse integer, C to the base of 16, join this, and when I log out header, I'm actually going to do that here. And I'm gonna leave some like lines so that we can see the header, the actual Redis 0011 being printed. Huh? How about that? This is the header in its hex form, and now this is the header decoded in a string form. Beautiful. All right, so we can like move on and go through, you know, parsing the metadata in the database and stuff like that. The database is gonna have a lot of parsing to do. The header is easy because it's literally just one string and that's it. Right? Literally just one string and that's it. But yeah. Just gonna do this now. Header decoded is going to be header with all of these matches and stuff like that. Oh, there was the issue was with that. Nice. Yeah, that's the header decoded, so I can even like do this now. Header decoded. Run the test again, and we'll see the contents of the header. I don't need the hex thing is I don't need to like log them out. This is the whole database file, and this is the header, and we'll continue with the metadata in the database and so on. But yeah, so far so good. To do parse the RDB file, I removed the first two because I already have the like an example of parsing the sections, and we already have the sections. So I just need to continue parsing the sections, because there's going to be a lot more than just, you know, this. These are not going to be one-liners. Right, look at the database section. You got an index of the database, you got the hash table size, the stores the keys, the stores the expiries. It's wild. So yeah, it looks like there are two hash tables. The one that stores the keys and values, right? The key value pair thingy that we already have, which is DB in our case. But we also have an expiry. We need to rework this in a way that expiry is actually a different record hash table, a different hash table, and just keep this one as a string. That's it. That's going to be the refactoring. Let me actually also make it to do refactor DB to be a simple key value record, and extract the expiry into its own record. And we will base that, we will save that, the name of the key that's in code. Where is it? Just remove this. FC has an expiry, and C was in milliseconds. So it gives us the milliseconds, the expiry first, right? And then we have the value type, and then we have the key. So we're gonna start reading this. We'll see that there's an FC. That means expiry, right? Okay. We'll save the expiry. We'll parse it as a number, save it, keep it there, right? Then we'll read 00. Cool, that's a string. Then we're going to read the key name, foo, and then we're gonna add to the expiry table. Then we're going to read the value, and then we're gonna add to the database table. So we have both the expiry and also the key value synced, and that's how we're going to read this line by line. And I guess that's, yeah, I guess that's like it. Very nice, very nice. All right, I should be going, and yeah, thank you so much for watching. This was a really cool episode, really cool episode. The next one is going to be on Wednesday at the same time, 9 a.m. EST on the East Coast. So yeah, have a great week, everyone, and I'll see you all on Wednesday. No, I'm actually lying. I lied to you. I cannot do Wednesday this time. Yeah, I have like an obligation on Wednesday, so I'll keep you posted. I might do Tuesday. Might move it to Tuesday, but we'll see. All right. Yeah. Thanks for watching. See you next week.